Welcome to C Sharp, our first look. This section will serve as the foundation for all the basic concepts behind not only C Sharp, but general concepts behind all object-oriented programming. As we move further into this course, you will notice topics covered in each section will work like a building block for the next. In other words, everything we learn in Module 2 will guide us into what we will learn in Module 3, and so on. With that being said, I encourage you to familiarize yourself with each section's concepts and vocabulary via note-taking. This practice will aid you in future sections and with much more advanced subject matter. Now, each lecture will consist of a vocabulary section that might feel boring no matter how you slice it. I personally dreaded key terms in school. However, it does act as a necessary evil because it's necessary. I ask you to challenge yourself to pay attention and grasp the importance of each concept, because it's not possible to program without understanding all the necessary ideas. So a program is a set of instructions for a computer to follow. It has a beginning, a middle, and an end, and it works something like a GPS. Pretend you were the GPS voice on your phone, and your computer was a driver. Well, as a GPS, you would tell the driver to make a left-hand turn, and then you would tell it to make a right-hand turn, and finally say that your destination is up front 300 feet. Well, this is how a program works. You would have a program, list a set of instructions, and then the program will follow those instructions until it completed all of the tasks. So once we've written a program, it gets divided to either system or application. For this course, we'll be dealing with application software, and the type of programming that we will be doing is split into machine language and high-level programming language. Machine language is the root, the lowest level of a programming language. It's expressed as a series of zeros and ones, or binaries, or on and off switches. It's a natural language the computer speaks. Now, because a lot of us just can't write thousands of lines of codes in zeros and ones, what we have to use is what we call a high-level programming language, like C, C Sharp, or Java, and it uses reads and writes and other relative terms instead of zeros and ones or on and off switches to perform tasks. It also lets us name our memory location, and because there's rules and there's names we have to abide by in high-level programming, we have a word called syntax, which represents all these rules. So in order to keep us in check using all these syntaxes and relative terms that are accepted by each and every different language, we use a compiler. A compiler translates this high-level language into the machine language in order for the computer to understand what we're saying. If this doesn't make sense, then think of it like you went to another country and you got off the plane and you were surrounded by people speaking the language you didn't speak. Well, if you had a translator there to help you, they would take all the language, all of the gibberish, and translate it into a language that you understand, so that you are able to function properly. And that is essentially what the compiler is doing. It's taking all our English language and translating it back into zeros and ones so the computer can operate efficiently. Now, debugging is a process for removing all that syntax and all those logic errors from a program discovered by the compiler and the logic errors discovered by testing the program. So what this means, when we break a rule or syntax rule, the compiler will let us know and forces us to make the appropriate change. Let me give you an example in C Sharp. We might use the console.writeLine, which is a relative term, in order to print to the screen. However, in Java, that same command is used with the print line. So if I was to write the wrong command in an attempt to write to the screen, I would receive a syntax error, because I'm programming in C Sharp, but I use a Java relative term. That's breaking the rules, and my compiler will tell me I broke a syntax rule. Now, what about a logic error? Well, logic errors are when you don't break any rules. You use all the correct language. However, your thought process is wrong. Let's say you wrote a receipt program and your objective was to add all the items someone might have ordered and then display the total. You would use the addition sign to find the sum in order to display all of the different additional totals. Let's say you want to use the addition sign, however, you accidentally chose a subtraction sign. Well, that's still an okay mathematical equation. The only problem is subtracting instead of adding up all the items. This would be a logic error because syntax-wise, you're allowed to use the subtraction sign, but logically, you didn't want to, and that is why logic errors are discovered once you start testing your program. Now, an identifier is the name of your variable or your method and is what we identify with when we want to reference a particular part of the code. So if I had a method called main and that was the identifier, I would identify that we need to go focus the main method. Or maybe my total variable I need to identify, then we would need to focus on that variable, the total variable. We can name these identifiers in different formats in these cases. We are using camel casting or Pascal casting. Now, it's common practice to use camel casting when you deal with a variable. Camel casting is when you have a capital letter for each additional word in the identifier's name, but you exclude the first word. In this example, look at the variable identifier, total students. Notice there is no capital letters in the word total, but the first letter in students is capital, and that's what camel casting is. If we add a third word, total students grades, then the third word grades, the G would be capital. The other is Pascal casting, and that means that the first letter of an identifier is capital, and it's used mostly with methods. For our example, the getNumber method would have a capital G and a capital N for get and for number. This is the Hello World program, and it's written in machine language. As you can see, all these zeros and ones, and of these, off and on switches, tell the computer to print the Hello World program to screen. Now we're going to compare that inside Visual Studio, how we would write the same program, but in C# or high-level programming language. Okay, so now we're in Visual Studio, and I'm going to show you how to write the same program, Hello World, that we just saw written in machine language. Visual Studio uses relative terms because it is such a tongue twister to say that. In C#, it's a high-level language program, so we use syntax. We use name for memory location. We use relative terms that gets translated back into machine language as soon as we compile. So in this, we are going to use relative terms like console to display a console. The write line, which makes anything put inside the quotations displayed on screen, and then we'll use a read line to precede input. Now in this case, there won't be an input, but we usually write a console.readline during testing to pause the program at a certain point. That way we can always make sure things are displaying correctly before it closes. So we start off, and again, we'll cover most of this stuff later on in different sections when we're ready to actually start writing code. But for now, just understand that what I'm doing is just choosing the correct rules within the syntax and choosing the right relative terms to get the set of instructions completed. So I start with console.writeLine. And there, its first set of instructions, a console.writeLine, and then I want hello world inside the quotes, which we put inside the parentheses. This should tell the computer that I want to print hello world to the screen. Now I want to pause it so that the console window doesn't close, because if we watch now and I push play, it just quickly flashes hello world onto the screen, which is not exactly what I want to do. I want to check and make sure it actually printed. So we put a console.readline here. And you like this, that Visual Studio actually will try to, it's called IntelliSense, and will try to figure out what you're trying to type, so it makes your job easier. So now we have a console.readline. So this will pause the console screen when I push start. And if there is no syntax error, this should compile completely and then pause on the screen. So seeing here, there was no errors. Hello world was printed to the console screen. Down here at the bottom, you can see there's an error list. If there was one, which says there's zeros, they'd be printed right here.